All right, we have another probability model practice question. On this one, again, this one's a little bit different. This one says an unusual six-sided dice or number cube, excuse me, is made for a new RPG board game that has the following probability model. And you can see here we have some unusual stuff going on. Says an unusual dice, or excuse me, number cube. So that's why it's weird. So this number cube has two twos, two sixes, no three, and no five. You might ask why, and that's, I guess, none of your business. That's the way the dice was used for the game for whatever reason. And you got to try to figure out ways to make up things. But I would like to point out here also, when we're going to show that the probability model is legitimate for 4 with an E. That's great. Let's go ahead and get rid of that. For each probability, the probability is between 0 and 1 inclusive, and 0 is okay. There are no threes. That is still part of a legitimate probability model. But I did kind of force it so that it could have a 0 on there. And then 1 6 plus 2 6 plus 0 plus 1 6 plus 0 plus 2 6 equals 1. And if you want, we'll go ahead and put 1.00 so it looks a little more like the percentage game, but it doesn't matter. So anyway, there you go. And again, we do have a couple zeros. That's why you have to put inclusive when you're writing that out. Okay, so the next thing now is find the probability, find the expected value. This time I wrote as expected value for the value for a roll. So again, you go stat edit, L1 for, I don't know why that did that, L1 here and L2 here. And then again, when we plug those nut values in, and then we go stat calculate, and then one var stats, and then you need to make the frequency list L2. And then you plug that in, and again, we get the answer. The average is 4.25 and a standard deviation of 1.5, let's say 1.59. So just round it a little bit. And then again, you do 1 times 1/6 plus 2 times 2/6. And you can change that to a 1/3, but you don't have to. As a matter of fact, sometimes they even like it better when you leave it as an improper fraction that you don't reduce, which is kind of weird, but just it's not wrong either way. It's not a big deal. But 2 out of 6 makes a little bit more sense than 1/3 on a 6-sided number cube. And then for the standard deviation, get yourself a nice big fat square root symbol. And we're going to do the first number 1 minus the mean from the previous step, and then times its probability, and then plus 2 minus 4.25 times 2/6 plus dot inside of the square root. So if and you know what else I was about to say, you always want to make sure that you don't forget any steps there. That's squared, especially on that second one. That gets missed a lot right there. You want to be really, really, really careful not to forget those squareds. So it is nice you get an abbreviated version of writing it all out, but you still have to put the steps in correctly. But I didn't actually intend to make that mistake, but it worked out pretty good. All right, and then interpret. If we randomly select many dice rolls or number cube rolls. You know what? I'm just going to write dice rolls. Sorry. And that it doesn't matter. They don't like using the word dice because that's what they use in gambling games. So they want to say number cubes, but I'm just going to, I guess, be a rebel and say dice instead. After many dice rolls, the average roll, sorry, that's pretty hard to read. I guess that's what's good thing we're talking at the same time, will be about 4.25. And then for the standard deviation, if we randomly select a single, and again, make sure that when we do the mean, it's a large number. And then when you do the standard deviation, it's a single. If we randomly select a single dice roll, we expect, we will expect. I guess maybe I should have a script here. Might be a little bit better. But we will typically be 1.59 away from the mean. Instead of saying, I'm going to say it will typically be 1.5 away from the mean. I think that just sounds a little bit better. All right, this is the third one of these that I've made. It doesn't matter which order you watch them in, but if you were in my class, I fully expect you to get this problem 105 on this one. And I would definitely call this problem shame and dishonor if you miss it. So don't.